Good morning, students. This is our, I think, eighth lecture. I think almost theory is finished. Now we solve problem illustration 11. A domain in ferromagnetic iron is in the form of cube of side length 1 micrometer. Estimate the number of iron atom in the domain and maximum possible dipole moment and magnetization of the domain. So this is one, you can say 1 micrometer, 1 micro by 1 micro. This is one cube. So volume of cube is equal to L cube. So 10 raised to minus 6 micro means cube. So 10 raised to minus 18 meter cube. Then we find out how many atoms are there. For that we need this. તો પહેલા તો હું એનું માસ શોધી કાઢું. The mass of the cube, mass of iron cube is equal to density into volume. So you must be given density 7.9 gram per centimeter cube. So this is in gram per centimeter cube, but here it is meter cube. So I will convert into centimeter cube. So this is 10 raised to minus 12 centimeter cube. You know the relation. Ten raised to minus 6 meter cube is equal to 1 centimeter cube. Okay, so we get this is 7.9 into 10 raised to minus 12 gram. So this is the mass. The number of iron atom in the cube. So we know this. If Na number, then mass is m0. So for this mass, how much? You know this, no? Molecular weight. So N is equal to mNa upon m0. What is m? 7.9 into 10 raised to minus 12. Avogadro number, you know, 6.02 into 10 raised to 23 divided by m0. That atomic weight 55 gram per mole. So 55 gram. It is in grams, so no problem. 55. So this many atoms are there. So if you simplify with calculator, તમે કેલ્સી કરવું પડશે. 8.65 into 10 raised to 10 atoms આવ્યો. ઓકે, હવે આપણે જોઈએ છે ને મેગ્નેટિક મોમેન્ટ. એકની મેગ્નેટિક મોમેન્ટ કેટલી છે? તો આટલી છે. તો બધાની કેટલી થાય? That is the saturation rate. So total magnetic moment M total is equal to N into M of each one. એક M ના આપ્યું છે તો હું M જ રાખીશ. M into M atom. Okay. So N is 8.65 into 10 raised to 10 multiplied by M atom is given by 9.27 into 10 raised to minus 24. 9.27 into 10 raised to minus 24. So it gives you multiplication કરવું પડશે. 8.0 into 10 raised to minus 30. આવું કંઈક આવશે. This is ampere into meter. Yes, ampere into N is total number, ampere to meter square. And હવે મારે જોઈએ છે magnetization. તો કે મેગ્નેટાઇઝેશન એ શું છે? તો કે m ટોટલ upon વોલ્યુમ. So 8 into 10 raised to minus 13 divided by વોલ્યુમ કેટલું છે? 10 raised to minus 18 meter cube છે. So this is comes out to be 8 into 10 raised to 5 ampere into meter. So this is the magnetization. Okay, and this is in ampere meter square, so ampere per meter, sorry, meter minus 8.0 into 10 raised to 5. So this is the magnetization. Okay, next one, answer the following question regarding earth magnetization. So this is actually discretely, I'm not at present doing and wasting the time, but then તમારે કરવાના તો છે જ. Second question is also like that. We go here, yes. So now a short bar magnet placed with its axis 37 degree with the uniform external magnetic field. So B is equal to 0.25 Tesla, theta equal to 30 degree. So torque is equal to 4.5 into 10 raised to minus 2 joule. Then what is the magnitude of magnetic moment? So what is the magnetic moment? So we have formula magnet force torque કેટલું લાગે? તો કે torque is equal to mv sin theta. સીધી ફોર્મ્યુલા m cross b. m તમને આપેલા છે, શોધવાનો છે. So m is equal to torque upon b sin theta. So torque is 4.5 into 10 raised to minus 2 divided by b is 0.25 into sin 30. Sin 30 is half. So 4.5 into 10 raised to minus 2 divided by 0.25 into half. So if you simplify it, you will get answer. I don't know at present, but you simplify yourself. Huh? I go for next. First I remove all this. So you have short bar magnet of magnetic moment this much. So m is equal to 0.32 joule per Tesla, or so you can write ampere into meter square. In uniform magnetic field, 0.15 Tesla. So B is equal to 0.15 Tesla. If the bar magnet is free to rotate in the plane of the field, which orientation would corresponding to stable equilibrium and unstable equilibrium. What is the potential energy of the magnet? Okay, means stable equilibrium means what? Stable equilibrium. અવારનવાર આમ તો આપણે કીધેલું છે. So where torque is equal to 0 and u is minimum. એને આપણે શું કહીએ? Stable equilibrium. So that is theta equal to 0. So what is the torque? Okay, mb sin theta. So torque is 0. U is equal to minus m dot b. Minus m dot b. And therefore minus mb cos 0. So that comes out to be minus mb. Minus mb. So you have given value of m, that is 0.32 into 0.15. Now it is leave it to you, that answer will be in joule. Now for unstable equilibrium. For unstable equilibrium, આ બી આપણે અવારનવાર વાત કરેલી છે. Theta is equal to 180 degree because torque is equal to 0 and u is maximum. Okay, so why torque is equal to mb sin 180 is equal to 0. U is equal to minus mb cos 180. Cos 180 is equal to minus 1. So this is plus mb. So So again you get negative answer here, and here you will get positive answer. 0.32 into 0.15, whatever is the answer in joule. કદાચ એવું પૂછે how much work to do from this position to this position, તો કે work is equal to u2 minus u1, so mb plus minus mb, so is equal to 2mb. This is the work done by the external torque. કદાચ પૂછાય તો આવું કરવું પડે. Okay, a closely wound solenoid 800 tons in area of cross section. This one, okay, number of tons is equal to 800 tons. Cross sectional area is equal to 2.5 into 10 raised to minus 4 meter square. Current I is equal to 3.0 ampere. Explain the science of which the solenoid acts like a bar magnet. What is the associated magnetic moment? So we know that whenever current is flowing, the one end of the solenoid becomes north and other end becomes south. Which end become north and which end becomes south, that is discussing later on. It would depend on current direction. It's very simple actually, but અત્યારે નથી હું કહેતો, difficult નથી. Okay, so what is the magnetic moment then? The magnetic moment, we have formula m is equal to NIA. N is the total number of tons, so here I get N. So 800 multiplied by 2.5 into 10 raised to minus 4 multiplied by 3.0. So this is 2.5 into 3, that is 7.5, and 7.5 multiplied by 8. So that comes out to be 0.6, and આવશે ampere into meter square, or you can say joule per Tesla. Yes. Okay, this is north, this is south. The magnetic field lines are coming, entering the south, and again goes toward the north. તો આવી magnetic field line closed loop માં હોય છે, તમને ખબર છે. ઇલેક્ટ્રિક ફિલ્ડ લાઈન હોય તો ક્લોઝ ના હોય, મેગ્નેટિક ફિલ્ડ હંમેશા ક્લોઝ હોય. Then next, so you have again solenoid, a previous problem. આગળનો છે, is free to turn about the vertical direction and uniform horizontal magnetic field this much. So B is equal to 0.25 Tesla. And magnetic moment we have already calculated, previous chapter, previous problem, 0.6 ampere into meter square. So 0.6 ampere into meter square. What is the magnitude of the torque on the solenoid when its axis makes an angle 30 degree? So this is the solenoid. The solenoid axis છે, હું તમારી સામે રાખું. This is the axis, and magnetic field સાથે 30 નો angle બનાવે છે. 30 નો angle બનાવે. This is magnetic field. This is axis. This is 30 angle. Magnetic field direction ક્યાં હોય? તો આ ડાયરેક્શનમાં હોય. મેગ્નેટિક મોમેન્ટ આ ડાયરેક્શનમાં હોય, અને એપ્લાઇડ ફિલ્ડ આમ છે, તો થીટા કેટલું રહ્યું? 30 ડિગ્રી. સો ટોર્ક આપણે ફાઇન્ડ આઉટ કરવાનું છે. With that, torque is equal to what? So we have torque acting on solenoid. Torque is equal to mb sin theta. M is equal to 0.6 and B is equal to 0.25 and sin 30 degree. So sin 30 is 6, so 0.3, 0.6, 0.25 into half. So this is 0.3 multiplied by this, so that comes out to be 0.075 joule. So that is your, and what is the direction? તો અહીંયા તમે જો આમ છે, મારું મેગ્નેટિક મોમેન્ટ છે, અને આ બાજુ ફિલ્ડ છે, તો m cross b એટલે ઉપર તરફ લાગશે. So the torque will be perpendicular to b and m. Okay, so that you can exact આપ્યું હોય તમે શોધી બી શકો. So you have here one bar magnet. Magnetic moment is this much. So magnetic moment is equal to 1.5 joule per Tesla. Lies aligned with the direction of uniform magnetic field, this one. So B is equal to 0.22 Tesla. So theta is equal to 0. That is theta 1 is equal to 0. એટલું તમને આપેલું છે. Now what is my first question? What is the amount of work required by an external torque to turn the magnet so as to align its magnetic moment normal to the field? So theta 1 માંથી મારે theta 2 કેટલું લઈ જવું છે? 90 degree. So this is your magnet and this is the direction of field. Okay, આવું છે. અને આને મારે ક્યાં લઈ જવું છે? તો I have to rotate by 90 degree. So initially it was theta 0 and now it is theta is equal to 90 degree. So initial potential energy, find out final potential energy, difference of that the work done. So what is my U1 or UI? So minus MB is equal to minus M dot B is equal to minus MB cos theta. So minus MB cos 0 so is equal to minus 1.5 into 0.22 into 1. So that comes out to be minus B નું multiplication આપણે કરવાનું થશે. કરી રાખું છું. So this is 0.33 joule. Okay, this is initial potential energy. And now potential energy when magnet is perpendicular to B. So U2 is, sorry, yeah, so I say UF is equal to minus MB cos 90 degree because now theta is equal to 90 degree. So is equal to 0. Therefore delta U is equal to UF minus UI. So UF is equal to 0, 0 minus UI, sorry, minus MB. જે આપણે calculate કર્યું છે minus 0.33. Answer is 0.33 joule. આટલી એનર્જીથી જે મેગ્નેટ મારું આમ હતું એ આમ ગોઠવાશે અથવા તો આવી રીતે બતાવું તો આમ હતું એ આમ ગોઠવાશે. It was in the direction of magnetic field. તમને દેખાય એટલા માટે આવું રાખું છું. And now we apply the field so it goes to 90 degree. So this is the first one and in the same first or the second opposite to the field. If opposite to the field તો હવે મારે થીટા કેટલું લેવાનું થશે? When magnetic moment is opposite to the field, so theta is will be equal to 180 degree and therefore UF will be minus MB cos 180 minus M dot B is equal to MB. Therefore change in potential energy is equal to MB final is U final minus U initial. So what is my U final? Okay, MB this is, and what is U initial? Minus MB. તમને જો ઉપર હતું એ, that is 2 MB. MB ની calculation આપણે કરી 33 આવેલા છે. So 2 times 0.33 is equal to 0.66 joule. Okay, so this is second answer. Okay, opposite to the field direction. What is the torque on the magnet in case 1 and 2? So પહેલા કેસની અંદર torque ની વાત કરું હવે. Torque here 90 degree. તો બાજુમાં લખી નાખું છે torque is equal to MB sin theta. Theta is equal to 90. Okay, so this is MB and MB ની calculation આપણે કરેલી છે. It comes out to be 0.33 joule and it is positive. અહીંયા negative આવે છે, potential energy positive આવે છે. તો torque ક્યારે? perpendicular હોય ત્યારે. અને torque અહીંયા કેટલો થશે? anti parallel હોય ત્યારે anti parallel છે. તો કે MB sin 180 sin 180 0 તો torque લાગશે નહીં. Okay, a closely wound solenoid of 2000 tons, the number of tons is equal to 2000. Area of cross section is this one. Area is equal to 1.6 into 10 raised to minus 4 meter square. carrying current I is equal to 4.0 ampere is suspended through its center, allowing it to turn in a horizontal plane. એટલે આવી રીતે રોટેટ થાય આમ નહીં, horizontal plane માં. Okay, what is the magnetic moment associated with? The first question નો answer છે magnetic moment. M is equal to NIA, our basic formula. So N is equal to 2000 into current is 4.0 ampere into 1.6 into 10 raised to minus 4. તો આની હું કેલ્ક્યુલેશન કરીશ તો થશે 4 2 8 અને 16 18, 10 raised to 3 આવશે, minus 4 આવશે, 4 2 8 હતા તો 4 ચોક 64, 64 તો 128, 128 થયા. કેટલા પોઈન્ટ કાપવાના છે? 1. તો આજે આવશે 12.8 into 10 raised to minus 1, or you can say 1.28 ampere into meter square. Okay, ampere into meter square. Now second question, what is the force and torque on the solenoid if the uniform horizontal field is applied this much, angle 30 degree. So બધા simple જ છે આમ તો. The second one, so torque is equal to mb sin theta. So m is calculated 1.28. What is the magnetic field is given 7.5 Newton raised to minus 2. And what is the angle? So theta is equal to 30 degree. Generally એવા જ આપે છે જેથી કે તમારી કેલ્ક્યુલેશન બહુ ઇઝી થઈ જાય. તો આની હું કેલ્ક્યુલેશન કરીશ તો મલ્ટીપ્લી ધીસ ઇઝ હાફ, તો એ આપણી પાસે આવી જાય છે 4.8 into 10 raised to minus 2. 4.8 into 10 raised to minus 2 joule. Okay, so this is the torque acting on solenoid. A circular coil of 16 turns, so number of turns is equal to 16, radius is equal to 10 centimeter, I convert into meter, carrying current 0.75 ampere. Okay, plane normal to the external field, magnitude is this much. કોનું magnitude છે? Field નું, so B is equal to 5.0 into 10 raised to minus 2 Tesla. The coil is free to turn about the axis in its plane perpendicular to the field direction. When the coil is turned slightly and released, તો કે આવી રીતે તમારી solenoid છે, coil છે, અને the coil is free to turn about an axis in a plane perpendicular to the field direction. 0.75 rests with the plane normal to the external field. A circular coil of 16 turns and 10 centimeter carrying a current of this much rests with its plane normal to the external field of magnitude. આવી રીતે આપણે field આપ્યું છે. ઓકે, અથવા આમ બી આપ્યું હોય perpendicular. The coil is free to turn about an axis in its plane perpendicular to the field direction. એટલે હું અહીંયા આપું તો આવી રીતે ફરી થઈ શકે એમ છે, આને perpendicular ને. Okay, when the coil is turned slightly and released, it oscillates about its stable equilibrium with a frequency this much. તો હું એને છોડી દઉં તો આ રીતે ઓસિલેટ થયા કરે છે, આમ અથવા તો આમ ગમે તે. તો આપણને ખબર છે એનો ફ્રીક્વન્સીની ફોર્મ્યુલા છે, તો ફ્રીક્વન્સી ઇઝ ઇક્વલ ટુ 1/2 પાય રૂટ mb upon I. આવું આપણી ફોર્મ્યુલા છે. અને આપણે શોધવાનું છે શું? તો કે મોમેન્ટ ઓફ ઇનર્શિયા. તો મોમેન્ટ ઓફ ઇનર્શિયા મારે શોધવું હોય તો f square is equal to 1/4 pi square into mb upon I, and therefore I is equal to mb upon 4 pi square into f square. m એટલે શું? તો કે NIA. into B upon 4 pi square into f square. તો બધી વેલ્યુ આપણે સબસ્ટિટ્યુટ કરશું. n is equal to 16 into current કેટલો હતો 0.75, magnetic field is 5 into 10 plus 2 minus 2 divided by 4 pi square તમે 10 લઈ શકો and f square is equal to 2 square. આને હું સિમ્પ્લિફાય કરી તો આન્સર will be in kilogram meter square. ઓકે, તમે કેલ્ક્યુલેશન કરી કાઢજો. A magnetic needle free to rotate in a vertical plane parallel to the magnetic meridian has its north tip pointing down at 22 degree. Like a magnetic needle is suppose this is the magnetic meridian and આને parallel rotate થાય છે. તો જેટલી ડાઉન જશે એટલી શું હશે એની ડીપ હશે. જો મેગ્નેટિક મેરિડિયનમાં ન હોય તો ડીપ ના કહેવાય, ઇટ ઇઝ નોટ એ ડીપ. મેગ્નેટિક મેરિડિયનને પેરેલલ રોટેટ થાય છે. સો વોટ એવર that it goes down, it is a deep angle. So it is 22 degree is called deep. So I is equal to 22 degree. And B is found to be 0.35 Gauss. And determine the magnitude of the earth magnetic field at the place. Horizontal, so this is not horizontal component, sorry. H E is equal to 0.35. So we have formula. H E is equal to BE cos I. This is horizontal component, vertical component ZE is equal to sin I, BE sin I. And therefore BE is equal to HE upon cos I. HE is equal to 0.35 Gauss divided by cos I. So cos 22 degree. તો તમારે cos 22 ડિગ્રીનું cos 22 ડિગ્રી મારે જોવું પડશે અને એની વેલ્યુ આપણે મૂકીશું એટલે આપણી પાસે આન્સર આવશે. cos 22 હું જોઈ લઉં છું. cos 22 degree. So that is 0.92. So this is 0.35 upon 0.9271. 9271. So that comes out to be whatever is 0.3. વચ્ચે મોબાઈલ આવી ગયો, સોરી. તો એ this comes out to be 0.377. 0.377 Gauss. So this is the magnetic field, BE, earth magnetic field. And you can also find ZE. So ZE is equal to BE sin 22 degree. And you can find BE also, ZE also. Okay. So at a certain location in Africa, a compass point 22 west of the geographic north. So આને મારે શું કહેવાય? This 12 is called declination. Declination. Okay. The north tip of the magnetic needle of the deep circle. Deep circle means measuring device placed in a plane of magnetic meridian to find the deep angle. So deep I is equal to 60 degree above the horizontal. The horizontal component of the earth magnetic field, that is HE, is equal to 0.16 Gauss. Specify the direction and magnitude of the earth magnetic field at that location. So you are given deep, this is deep angle, and this is declination में जरूर भी नहीं पड़वानी कहीं. So we have HE is equal to BE cos I. Again same formula, and therefore BE is equal to HE upon cos I. HE, that is 0.16 cos 60 degrees. 60 degrees half, so it is cos 60 is half, so 0.32 cos. Okay. So you can say that suppose this side is north and west, અહીંયા east આ side west. તો તમને કીધું ને west side માં છે. શું કીધું છે? It is toward the west. This is north, this is east, this is west. તો વેસ્ટ સાઇડની અંદર 12 ડિગ્રી એટલે આ બાજુ છે અને પછી નમેલું છે કેટલું 60 ડિગ્રી. So this is the direction of magnetic field. Okay. So again, a short bar magnet has a magnetic moment 0.48 joule per Tesla. So this is the magnetic moment of the magnet 0.48 joule per Tesla. Give the direction of magnitude of the magnetic field produced by the magnet at a distance 10 centimeters. So distance is equal to 10 centimeter. It means that 0.1 meter from the center of the magnet on the axis and the equator. So it looks like that. Suppose this is my magnet. So this is your axis and this is your equator. This is equator and this is axis. Okay. તો મારે અહીંયા બી શોધવાનું છે at 10 centimeter and અહીંયા બી શોધવાનું છે at 10 centimeter. So we have formula B on axis is equal to mu 0 upon 4 pi 2m upon dq. Okay, આપણી formula છે. So mu 0 is 4 pi into 10 raised to minus 7 upon 4 pi into 2m is equal to 0.48 divided by dq. D is 0.1 cube. So that you simplify 4 pi cancelled out. This 0.1 cube is 0.001 10 raised to minus 3. So 2 into 0.48 into 10 raised to 3. So I just simply 48 multiplied by 2. So 0.96 I think, yes, into 10 raised to 3. So 960 0.1 into 10 raised to minus 7. Of course, 10 raised to minus 7 is there. Sorry. Into 10 raised to minus 7. એટલું બધું મોટું ના જ આવે એટલે મને એવું થયું કે મિસ્ટેક છે. So that is in Tesla. And if you say the equatorial line, so that is the half of this one. કારણ કે 2 નહીં આવે. So mu 0 upon 4 pi into m upon dq. તો હું સબસ્ટિટ્યુશન કરીશ તો 0.480 આવશે. 480 into 10 raised to minus 7 Tesla. Okay. So that is the answer. So students, today's fun. 3 magnets of equal magnetic moment but of different length are placed as shown in the figure. Find magnetic moment of the system. 5 centimeter, 10 centimeter, 15 centimeter, 60 degree, 60 degree. તમારે પોઝ કરી દેવાનો તો જોઈ લેવાનું. ઓકે, થેન્ક યુ વેરી મચ.